Hey everyone, welcome back to the channel. Today we're thrilled to unveil version 1.50 of AutoCodeAgent. In this release, we're introducing three cutting-edge RAG techniques as powerful new tools to supercharge your data extraction, analysis, and synthesis workflows. Tailors have expanded our arsenal with three innovative RAG techniques: Llama Index Context, Window RAG. This tool takes document retrieval to the next level by dynamically enriching each text chunk with adjacent sentences. With a configurable window of neighboring context, it ensures that your retrieval outputs are both highly relevant and contextually complete. Whether you're retrieving market trends, research insights, or legal documents, this technique stitches together a fuller narrative, overcoming the limitations of isolated text fragments. Hypothetical document embedding, HyDE. This approach expands short queries into detailed hypothetical documents. Leveraging advanced language models, it generates an enriched query that aligns more closely with stored document embeddings, effectively bridging the gap between concise inputs and complex documents for more accurate, context-aware search results. Adaptive Retrieval Augmented Generation (RAG). An adaptive RAG system tailors document retrieval to the query type. By classifying queries as factual, analytical, opinion, or contextual, it dynamically refines its search strategy using targeted LLM prompts. This approach delivers precise, context-rich responses by selecting the most relevant documents based on the query's nuances. Download the repository, the link is in the description, run it with Docker following the instructions in the readme.md file, and test its functionality. If you like it, leave a star and contribute with a fork. Pull request, issue, or feedback. And if you are a programmer, come on, let's collaborate together to make an innovative project grow. Don't stop watching, because in the next section, we'll dive deep into the Adaptive Retrieval Augmented Generation RAG. We'll break down its fundamental concept, walk you through a live demo using it, and explain the code in detail. Plus, check out the description for 2 additional videos where we explore hypothetical document embedding, HyDE, and Llama Index Context Window. Stay tuned for a comprehensive look at these cutting-edge techniques. In the file retrieve.py, the code implements an adaptive retrieval augmented generation technique that dynamically chooses a retrieval strategy based on the query type by first using the query classifier, which substitutes the input query into a classifier prompt and calls the model to return a category. Then the base retrieval strategy is established as a foundation, setting a top K value from an environment variable. And from this base, several specialized strategies are derived. The factual retrieval strategy enhances the query using an enhancement prompt, retrieves an extended set of documents, and iteratively ranks each document by substituting both the enhanced query and the document into a ranking prompt that calls the model to generate a relevance score, after which it sorts and selects the top documents, while the analytical retrieval strategy first generates exactly a specified number of sub-questions by substituting the query and desired count into a subquery prompt and calling the model, then retrieves documents for each generated subquery, aggregates the results, and finally applies a diversity prompt that instructs the model to select indices corresponding to the most diverse and relevant documents before returning the selected ones. The opinion retrieval strategy identifies distinct viewpoints by substituting the query and desired count into a viewpoints prompt and calling the model, then appends each viewpoint to the original query to retrieve documents, aggregates them, and finally ranks the opinions by substituting the documents into an opinion ranking prompt and calling the model to select the best indices, while the contextual retrieval strategy handles queries requiring context by using either a provided user context or a default context, reformulating the query through a reformulation prompt that combines the query with the context, retrieving documents based on the reformulated query, and then ranking these documents using a contextual ranking prompt that factors in both the reformulated query and the context before selecting the top ones. Moreover, the adaptive retriever class orchestrates the entire process by first classifying the query, and if the classification indicates a contextual query, it extracts context via a regular expression search and sets the appropriate strategy. Otherwise, it selects the strategy based directly on the classified category. And finally, the adaptive RAG class encapsulates the model and retriever, obtains the relevant documents by invoking the retriever, substitutes the aggregated context and original question into a final answer prompt, calls the model once more to generate a comprehensive answer, and returns this answer as the final output, while logging all key steps for debugging and traceability. In prompt.py, the code defines a series of string templates using the template class that serve as the building blocks for constructing detailed prompts, which are later used in the retrieval strategies. The adaptive query classifier prompt instructs the model to classify an input query into one of 4 categories, and in the case of a contextual classification, to extract and output a context enclosed within special tags, while the adaptive factual enhance prompt and adaptive factual rank prompt respectively guide the model to enhance a factual query for improved retrieval, and then to rate the relevance of a given document on a fixed numerical scale based on the enhanced query. The adaptive analytical subquery prompt is designed to generate exactly a specified number of analytical subquestions from the original query, and the adaptive analytical diversity prompt takes a list of documents and instructs the model to select a specific number of indices that represent the most diverse and relevant pieces of information. Similarly, the adaptive opinion viewpoints prompt prompts the model to list a fixed number of distinct viewpoints regarding the query, and the adaptive opinion rank prompt then uses the retrieved documents corresponding to these viewpoints to have the model select indices that best represent diverse opinions. Further, the adaptive contextual reformulate prompt allows the model to incorporate a given user context to reformulate the query in a way that better addresses user needs, while the adaptive contextual rank prompt instructs the model to evaluate and score the relevance of documents based on both the reformulated query and the user context. And finally, the adaptive final answer prompt is used to integrate the selected context and the original question into a final prompt that directs the model to generate the ultimate answer, thus making this file a critical component in standardizing and guiding the interactions with the language model throughout the retrieval augmented generation process. Thank you for watching. We hope this deep dive into AutoCodeAgent's advanced capabilities has inspired you to unlock the full potential of AI-driven automation. Stay innovative and see you in the next video.